Before we jump into the declaration, it is somewhat more prominent and convincing to figure out what subatomic gas pedals are. The enormous Hadron Collider, LHC, work by CERN, is a 17 ring of superconducting magnets. Furthermore, it is the world's most unmistakable and most imperative molecule smasher. It represents the zenith of human satisfaction. In actuality, it is strong to the point that it might duplicate the exact conditions of the primary second on the planet. Anyway, could the machine, designed to open the secrets of the universe, hold the way to something truly exceptional? Founded in 1954, CERN is one of the world's most renowned research institutions, with 23 member states and countless specialists. It's a region for collaboration and advancement. The LHC is CERN's principal project, but it is just one part of a huge network of fuel pedals and tests. Think of it as a course, not much for engines or people, but for subatomic particles, in a preliminary of flare resilience in space itself. The LHC speeds up protons to nearly the speed of light, sending them on an impact path that mirrors the energy of the universe just after the Big Bang. The effects create temperatures much hotter than the center of the sun. A massive number of magnets guide the protons on their journey, while complex cooling systems hold the magnets at temperatures lower than space. The beams in the LHC are made to crash at 4 areas across the gas pedal ring, connecting to the spots of 4 molecule identifiers: Atlas, CMS, ALICE, and LHCb. Each fills a particular purpose, researching different aspects of particle physics. Together, they act as massive cameras, taking photographs of these impacts. Scientists then sift through the particles, searching for indications of the tricky Higgs boson, also referred to as the God particle, and other anomalies that could give hints about the universe's fundamental building blocks. By focusing on the microcosm, we gain insights into the universe. However, with each answer comes another question, and with each discovery, another test arises. The LHC isn't just a scientific device. It's a show of human curiosity and progress. It represents our pioneering mission for understanding and our longing to perceive the key forces that shape our universe. However, as we stretch the boundaries of what we know, we must also remember the more significant and existential questions that arise. What are the risks of examining the unknown? Should our quest for knowledge accidentally unleash forces we have no control over? Inside the sacred halls of CERN, where the limits of human knowledge are continually tested, a revelation has emerged that sends a shudder down the spine of even the most prepared researchers. Brian Cox, a former scientist at CERN and a voice of understanding in the field of particle physics, has recently made a statement that has left the world both fascinated and uncomfortable. Cox's words resonate with chilling clarity. The justification for CERN's Large Hadron Collider is to reproduce a small Big Bang. Yes, you heard that right, a miniature version of the very event that birthed our universe. The physicist also went on to explain the implications of this objective, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to uncover the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine harnessing the power of creation, the ability to gather the very essence of the universe. It's an alluring possibility, but one full of danger. The small Big Bang isn't just a theoretical concept. It's a very real phenomenon. Inside the LHC, the temperatures, the pressures, the raw energy, all of it reproduces the conditions of the universe's origin. It's like standing at the threshold of written history, witnessing the birth of existence itself. Yet, with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something did go wrong back in 1978. Russian physicist Anat Borsky experienced a calamity that could forever change his life. While working at the U-70 synchrotron at the Institute for High-Energy Physics in Pino, Russia, a failure caused his head to accidentally enter the direct path of a proton beam. The beam, with a force beyond comprehension, passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was nerve-wracking. He saw a flash brighter than 1,000 suns, but had no immediate concerns. The beam's path resulted in a trail of destruction, burning tissue and bone. Yet he remained conscious and even walked to the center for treatment. The result was both disturbing and strange. The beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. Strikingly, Borsky's mental faculties remained intact, and he continued his medical career. This incident serves as a reminder of the immense power and potential dangers of particle accelerators. The risks of a particle smasher like the LHC shouldn't be underestimated. The potential for catastrophic reactions, the very fabric of life being altered. These are not the stuff of science fiction, but genuine concerns voiced by respected scientists. One of the most unsettling and fascinating issues related to the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of space-time where gravity is so strong that not even light can escape. They are enormous vacuum cleaners, devouring stars and mysterious objects hiding in the shadows of our universe. The fact that the LHC might create one of these phenomena, even on a small scale, is stunning to both the public and scientists alike. Could this black hole eventually grow, becoming wild and swallowing the Earth from within? Scientists at CERN have reassured the public that any black hole created would be unstable and vanish quickly. However, the distant possibility has sparked discussions, fears, and a sense of wonder at the power we wield. It's crucial to understand how the LHC could create a black hole. It all revolves around the basic mechanics of particle accelerators. When protons are collided at nearly the speed of light, the energy produced is so immense that it warps the fabric of space-time itself. Imagine a trampoline stretched tight, then a heavy object dropped onto it. The fabric bends, and if the object is heavy enough, it can create a well so deep that anything nearby will be trapped. This is akin to what happens in a particle accelerator. The energy from these high-speed collisions can warp space-time, potentially creating a tiny black hole. However, the laws of physics suggest that these miniature black holes would be extremely short-lived. They would rapidly decay, releasing energy in the form of radiation. Despite these reassurances, the very possibility of black holes forming in the lab has captured the public's imagination, with some fearing that, even though small, these black holes could grow uncontrollably. The reality, however, is that the likelihood of such an event is incredibly small. The conditions required to create a black hole in the LHC are so specific and rare that it is highly improbable for one to form. But the questions linger, and the curiosity of scientists and the public alike continues to drive research forward. Could there be other unexpected outcomes of these experiments that we cannot predict? While the LHC is designed to deepen our understanding of the universe, it also presents new challenges in terms of responsibility and ethics. As we continue to push the boundaries of science and knowledge, we must carefully weigh the risks against the potential rewards. The discoveries that come from particle accelerators like the LHC have the power to reshape our understanding of reality itself, from the birth of the universe to the fundamental forces that govern everything around us. But, as with all great scientific endeavors, the line between discovery and unintended consequences is often razor-thin. In the years to come, as we unlock more secrets of the universe, we may have to face questions that are less about science and more about our humanity. What price are we willing to pay for knowledge? Are we prepared for the unforeseen consequences of our experiments? And, in the end, can we truly control the forces we are unlocking? These are questions that go beyond physics. They are philosophical, ethical, and existential. The answers may not come easily, but they are vital to our future as we strive to understand not just the universe around us, but our place within it. As the world continues to turn its gaze toward the Large Hadron Collider, one thing remains certain. Science has an unstoppable momentum. And with each new discovery, we inch closer to the most profound question of all: what lies beyond the edge of our current understanding? Brought into it, this is a similarity to what could occur in the LHC, Large Hadron Collider, inside the domain of quantum physical science, where the laws of the universe are both unusual and wondrous. There's a theory that more aspects may be concealed inside our world. If these aspects exist, the LHC's trials could take advantage of them, creating a gravitational well that shapes a small dark opening. This particular dance of particles has even grabbed the attention of a few renowned researchers, prominently the late Stephen Hawking. In his book, he cautioned about a situation wherein the Higgs boson could become dangerous at exceptionally high energy levels. This instability could cause a catastrophic event called vacuum decay, an event that wouldn't just obliterate Earth, but might potentially destroy the entire universe. The eminent English cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments conducted at CERN. In his book on the future, Prospects for Humanity, he explored the potential dangers of particle smasher tests, including those at CERN. His words weren't cautious. They were filled with a sense of existential dread. He examined a worst-case scenario in which a failed experiment could trigger a phase transition that would echo through the fabric of space-time, resulting in a catastrophe that could engulf the entire universe. Rees' concerns were not limited to theoretical ideas. He assigned a slim probability to these devastating outcomes, yet he argued that even a small risk warrants serious consideration. The stakes are high, and the margin for error is razor-thin. The scientists at CERN have run simulations, analyzed theories, and taken precautions to ensure the safety of the LHC. In fact, Brian Cox himself emphasized the importance of these measures, acknowledging the inevitable concerns and questions surrounding the LHC's operations. He reassured the public that there are rigorous safety protocols in place, along with thorough reviews and processes to ensure the LHC's activities are conducted with the utmost care. Cox reassured the public that the energies involved are well within what the Earth naturally encounters and that the chances of developing a stable black hole are astronomically low. Even if one were created, scientists argue it would be so small and unstable that it would rapidly dissipate in a burst of energy, a phenomenon predicted by Stephen Hawking, known as Hawking radiation. It would be a fleeting moment of cosmic wonder, a brief glimpse into the depths of darkness, and then gone. Some have taken the idea further, speculating that the LHC's experiments could open a portal to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captivated the imagination of many and become a subject of fascination, fear, or even myth. What lies beyond our universe? Could we accidentally unleash forces or entities we don't understand? The idea of creating a gateway to hell has even been dramatized in various media, stirring uncertainty. But how did this idea take shape? And what does it mean in terms of scientific exploration? The concept of extra dimensions isn't new in physics. String theory, a leading candidate for a unified theory of everything, suggests that there may be more than the standard 3 dimensions of space and 1 of time. These extra dimensions could be compactified or hidden from our perception. Yet in theory, they could be accessed or discovered under extreme conditions. Now consider the LHC as a massive key unlocking doors that have been locked since the dawn of recorded history. When protons collide at energy levels never before achieved on Earth, they could, in theory, create ripples or waves that probe these hidden dimensions. If these dimensions exist, the LHC may indeed uncover them. However, before we get too excited with wild speculation, it's important to remember that while the LHC is certainly powerful, there is no definitive evidence to suggest it will create a portal to another universe, let alone to hell itself. Yet the allure of the unknown, combined with the mysterious nature of quantum physics, ensures that such ideas will continue to captivate the public imagination. Should we be worried about the LHC and its potential risks? It's easy to be swept away by sensational headlines and fears of global catastrophe. However, the reality is that the scientists at CERN are deeply aware of the dangers involved. They have taken precautions to ensure their experiments are safe and continue to monitor and test their work with the utmost diligence. The potential benefits of the research, the breakthroughs in our understanding of the universe, the discovery of new particles, the exploration of dark matter, are truly remarkable. It is a testament to human ingenuity and a window into the very heart of the universe. Yet, like any great advances in science, it comes with its share of risks, and we must approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the frontier of scientific inquiry, where theoretical physics meets experimental reality. Its potential to answer fundamental questions about the universe, including the origins of mass and the nature of dark matter, is immense. But despite rigorous safety measures and extensive simulations, the LHC still inspires a sense of mystery and fear in some. The sheer scale of the device and the energy it produces are awe-inspiring, and each new experiment opens the door to uncharted scientific territory. While most scientists remain confident in the safety of LHC experiments, there are inherent uncertainties. What if new, unforeseen phenomena emerge that challenge our understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over the natural world. As particle collisions replicate conditions unseen since the Big Bang, the significance of these experiments grows, raising existential questions about the potential effects of altering the very fabric of the universe. These existential concerns, though valid, must be balanced against the vast potential for discovery and advancement that the LHC represents. At its core, the LHC is not just a tool for probing the physical universe, but also a symbol of humanity's relentless curiosity. The quest to understand the fundamental forces and particles that make up reality has driven scientific progress for centuries, and the LHC is the culmination of that effort on an unprecedented scale. The discoveries already made by the LHC, such as the confirmation of the Higgs boson in 2012, have fundamentally altered our understanding of the universe. This elusive particle, often referred to as the God particle, provides mass to other particles and is a cornerstone of the standard model of particle physics. Its discovery was a monumental achievement, one that validated decades of theoretical work and cemented the LHC's place in scientific history. Looking ahead, the LHC continues to explore phenomena that could revolutionize physics. It seeks answers to some of the biggest questions. What is dark matter, and why can we not directly detect it? Are there undiscovered forces or particles shaping the cosmos? Could there be a unified theory that reconciles quantum mechanics and general relativity? The potential for groundbreaking discoveries also brings an ethical dimension to these experiments. As scientists push the boundaries of the known, they must grapple with the responsibility of their work. What are the acceptable risks when seeking knowledge that could fundamentally change humanity's understanding of existence? Is it possible to explore without endangering the very fabric of reality? While the fears surrounding the LHC may sometimes verge on the fantastical, they highlight the profound questions that modern science evokes. At the intersection of imagination and experimentation lies the human capacity for awe and wonder, qualities that drive us to explore the unknown. The debates surrounding the LHC also underscore a broader societal challenge: how to engage the public in understanding and supporting scientific research. Misinformation and sensationalism often cloud discussions of complex scientific topics, creating unnecessary fear or skepticism. Scientists and communicators must work together to foster a culture of scientific literacy, ensuring that the public can appreciate both the risks and rewards of cutting-edge research. In the end, the Large Hadron Collider is not just a scientific endeavor. It is a testament to human ambition and ingenuity. Its towering machinery, intricate experiments, and theoretical implications represent the pinnacle of human achievement, a bridge between the known and the unknown. As we continue to push the boundaries of what is possible, the LHC reminds us of the delicate balance between risk and reward. It challenges us to ask not only what we can discover, but also how we choose to wield the knowledge we gain. Will the discoveries made at the LHC bring us closer to understanding the universe's ultimate secrets, or will they reveal new mysteries that push the limits of our comprehension? One thing is certain: the journey of exploration and discovery will continue. The LHC is a beacon of human curiosity, a reminder that even in the face of uncertainty, we are compelled to seek answers. Whether unlocking the secrets of the cosmos or uncovering new dimensions of reality, The LHC embodies the enduring spirit of science, a quest for understanding that transcends fear, inspires wonder, and defines what it means to be human.